A very good morning to all of you who are here today. Welcome to the International Conference on Medical Sciences 2024. It's a pleasure to see so many bright minds gathered here today, united by our passion for discovery and innovation. I'm Shaka Herath, and I will be your compeer for today. Over the next few hours, let us journey through interesting pathways that would ultimately lead us to an enlightening experience in not one, but various disciplines. Thus, this day is reserved for us to engage in thought-provoking discussions and network with fellow researchers as well as aspiring individuals throughout the island. Now, as we commence the conference, I cordially invite Professor Guani Lianage, Chairperson of the Research Committee, to share a few words with us.
Good morning, everybody. Of course, I'm not going to talk for long. Dean FMS and all the resource persons who are here with us today and all the participants, welcome all of you to the International Conference on Medical Sciences. So as you all can see, our focus is on research methodology, artificial intelligence, and also manuscript writing. So hoping to increase the research output in the time to come. There are a lot of experts who are lined up, who are coming from various organizations in the country, and also international speaker. So hope you all enjoy the sessions, participate actively and share your knowledge, and also there are debates and discussions that are lined up. And also we have set a stage for you to present your abstracts so that you can showcase your research. So enjoy the day. Thank you very much.
Thank you, Professor Lianage, for that inspiring words. Next, I'd like to invite Professor Manori Gamage, Dean of the Faculty of Medical Sciences, University of Shujawardhanapura, to address the gathering.
Good morning, all invitees. This year our theme is Advancing Research Through Technology. We gathered here to share our knowledge, exchange ideas, and discuss latest advancement in medical sciences. As we know, the field of medicine is constantly changing and it is driven by innovation and discovery. We must be prepared to face these challenges. In particular, machine learning and artificial intelligence plays a major role in future. So we have to be ready for those things. So today's the research committee has arranged excellent lineup of speakers to talk about those areas. So fully engage with the activities and ask questions and involve with the discussions and share your knowledge and experiences with them. And I congratulate all the presenters who are presenting the oral presentations and also poster presentations, and I encourage all of you to join these sessions because that will be an encouragement for these young researchers. And not only presenting as oral presentations and poster presentations ending just as abstract publication, please go ahead and do proper publication in index journals. And I thank Professor Guani Lianage, Dr. Lilanka Pereira, and Dr. Tushari Disanayaka for arranging these events. Thank you very much and enjoy the rest of the day.
Thank you, Professor Gamage, for that wonderful address. Before we dive in, here are a few housekeeping notes. Please silence your mobile devices. And the book of proceedings containing abstracts and the program can be accessed via scanning the QR code, which is available at the registration desk. Poster presentations can be viewed through the LED screens located in the adjacent poster viewing area. And we also encourage questions during question and answer sessions, so don't hesitate to engage with our speakers. Now, without further ado, let us move on to the first session of the day. This symposia will be chaired by Professor Shamini Prathapan, Professor of the Department of Community Medicine, and Professor Pradeepa Jayawardena, Professor of the Department of Pharmacology. I cordially invite our chairpersons onto the stage.
Morning to all. In keeping with what the chairperson of the research committee and what the dean was saying about research, I'm going to start off the session with three eminent speakers, Professor Malavige, Professor Premawardena, and Professor Silva. So it's going to be an exciting three sessions, and we'll kick off the research conference with Professor Neelika Malavige, and Professor Pradeepa will introduce the speakers.
Very good morning to you, and I don't think Professor Malavige needs any introduction. Neelika Malavige is a professor at the Department of Immunology and Molecular Medicine, University of Sri Jawadanapura, and an academic visitor at the Weatherall Institute of Molecular Medicine, University of Oxford. She is a member of the Executive Committee of the International Society of Infectious Diseases and sits on or chairs numerous national and international scientific advisory boards, funding panels, and editorial boards. Her research focus has been on immunopathogenesis of dengue, biomarkers and immune correlates of protection, and translating these findings into the clinical trials. So today's topic is selecting a research topic for an early career researcher. I think Neelika is the best person to discuss that. Over to you, Neelika.
Thank you, Pradeepa. And just to let you know, my voice is not the best because I'm not feeling very well. So just after my talk, I will leave so that I don't infect others and give my flu. So please excuse me for my voice and being different. So, and I hope we can have a very interactive discussion, because I don't think we have a massive crowd, and this is for early career researchers, although I see very senior people also in the crowd. But anyway, to start off with, why should you identify a research area? So this is why I have been asked to talk about, but the main question is, why should you identify a research area in the first place? So now let's take a respiratory or chest physician who obviously has expertise in managing patients with asthma, COPD, pneumonia, TB, ILD, you know, the whole list. So this is expert, and if I have any of these diseases, I would not hesitate to go and meet a respiratory physician. Now, if such a person is going to choose a research area, because you are a respiratory physician, would you choose, you know, one project on asthma, then also on sleep apnea, then bronchiectasis, maybe TB, interstitial lung disease? I mean, because after all, you are a chest physician. Would it be okay to just choose random research areas, and because, I mean, that's your specialty? What do you think? We are not talking about clinical management here. Obviously, clinical management, yes, we are talking about a research area. We are talking about a respiratory physician, and I hope there's no respiratory physician in the audience, so I'm not picking on anybody. What do you think? The pros and cons of this, okay? So let's talk about me. So I'm doing a little bit of talking about me as well here, because I thought it's best to also sometimes talk about me. So my speciality, if you ask a lot of people, they would say I'm an immunology, okay, because that's what I've specialized in, but specifically viral immunology. Some people also think I'm a virologist. I'm not a virologist. I have not much knowledge on clinical virology at all. I do have clinical expertise in allergies, but that's it. But if you look at my publications, I've got 14 publications on VZV, On dengue, I have 87, COVID 35, microbiome 1, and 6 on allergy. What is my research expertise? What would you consider me an expert in? Okay, so now this is it. I mean, just because I'm called an immunologist, I don't like there are enough and more people who ask me to do this work on this topic on immunology, that topic on immunology, let's do this. But, you know, I refuse because of a particular reason. Now, of course, for my PhD, I did a lot of work on VZV, but I did not work on VZV after 2011. So if you ask me about VZV, I mean, except for clinicals, I mean, I have no idea what's going on in VZV field right now. So definitely not a research expert in VZV. COVID, I mean, unfortunately, when I walk down the road and people introduce me, I'm introduced like the person who was on TV, which is sad, okay, a COVID expert. So after 2022, early 22, I did not work on COVID. We'll talk about that, why that stopped. So I don't consider myself as a COVID expert at all, because it's been over 2 years since early 2022, and so much has happened in the COVID field. I have no idea what the most dominant variant is. And there's a reason I don't know, because I can't spend time on looking at things like that, or what is going on with long COVID. So if you ask me the most important research questions to answer in the COVID field, I don't know. Okay, and allergies. Okay, in Sri Lanka, I'm considered an expert in allergies. Clinical management, yes. I have time to keep updated on clinical management of allergies. When it comes to research, I have no clue. Okay, because research is very different to clinical management. Okay, being updated to manage a patient versus going very deep into an area to work on something is different. Now, during COVID times, yes, I was invited to even international webinars, symposium, all these things, because at that time we were doing very well. We were doing very timely research. After that, nobody in the world considers me as a COVID expert, because I'm simply not. What I am known is a dengue expert, and that's all I am. Because, and so internationally, I have a name for dengue. Now, coming to the question, because I thought I will talk about myself here and do a little bit of bragging as well, okay? Sorry about that, not intentionally, but this is just to drive a point home. So why can't I, or basically, I refuse to do research in other areas. So now is the bragging part, okay? Excuse me for bragging about myself. So, I mean, people consider me as a good researcher, okay? That's what people say about me, because I've won many research awards, supervised quite a few MPhil PhDs, reviewed for over 50 journals. I mean, a regular reviewer for including Nature Science journals. I'm a grant reviewer for MRC UK, Wellcome Trust, Malaysian government, Singapore government, and the chair of the research committee of International Society of Infectious Diseases. So, I mean, if I'm a good researcher, why can't I, you know, like research on anything? Because that's what people think. They come to and think, you know, always ask, can't we collaborate on this, on that? This is a good research idea, but my research expertise is very limited. So the thing here is, the point I want to drive home, it is impossible to find the most important questions to answer in other fields. Okay, because research is about discovering something new. So to know, discover something new, to develop something new, and to contribute to new knowledge, you have to know whether your research area, the research questions you want to answer, the new innovation you want to do in that particular field are relevant or not. Without digging really, really deep into that area, without knowing what everybody else in the world is doing, without knowing every single paper and preprint that is coming out in that area every day, you can't do meaningful research and innovation. You do not become an expert in that area. So this is why, so all this time, I have not been talking about how to choose your research area, but why you should choose a research area. Okay, why should you select a research area? Okay, because it is impossible to find all these things if you're like really dig deep in. So clinical management and doing research are different. Because we should not, if you look at research funds, it's very limited. And the time we have, I mean, all of us are very, very busy people. We hardly have time to do anything at all. So the very limited time all of us have should be used to do something meaningful, to advance the knowledge and ourselves and others, to benefit everybody else and not waste time wasting funds or repeating what is already there or somebody else is doing much better than we are. So now coming to how do you identify a research area. So when you want to answer this question, you have to consider three things. What interests you? What is important to do? And what are your strengths and weaknesses? Okay, so to look at these three main areas. So the first one, what interests you? So what area, okay, now you have a wide field, we are talking about respiratory vision, mind you. What area do you think you could spend studying several hours a day, at least, okay? So you can't do research unless you spend several hours a day on a particular area, because the knowledge, every day there is so much new knowledge being generated everywhere in the world. So if you can't keep up with the new knowledge generated, then of course you can't do meaningful research. So you have to choose an area that you're very passionate about, that you could spend many hours a day every day. And you're happy to talk about it with other people. So when you like something, it shows. Like when you love somebody, it shows. When you like something, it shows. So I can tell you. So now I have like dengue, for instance, and very early, like in 2012, we had end of 2011, our university and I think other universities were also given this world-class university project. And for some reason, the vice chancellor at that time made me the director of that project in the university, reasons unknown to me. But anyway, because of that, I met so many other colleagues in other faculties, including a very senior person called Professor Dehragoda, who was the professor of geography. And he was the dean and the chair of the multidisciplinary board. And when we got talking, and I was talking about why I was doing dengue, and he thought that, and he later told me that the way I spoke, he knew that I was so passionate about this research that he thought that he should help me. And because of that, because I of course have no connections at all, I don't know how to get funding from the government at all, okay, my expertise is just in research, but he has other expertise. So he's the one who established the Center for Dengue Research. He is the one who got funds for the Center for Dengue Research. It was not me. And the reason he did it was he believed that I could deliver, because I had the passion to do that. So you have to choose an area where others will, when you talk about it, it shows. And of course, if you are working on something, are you willing to work the next 10 to 20 years on that area? Okay, because if you are willing to meaningfully achieve something, it's not going to happen overnight. So I have to put a lot of effort and time into it. If you look at the, like the established researchers globally, they have been working on a particular area for years and years and years. So are you naturally drawn for it? And also, of course, there might be personal reasons for you to be working on a particular area. So that's about what interests you. The next question is, what is important to do? Now again, I'll talk about my story. Now, for my PhD, I worked worked on mainly T cell biology on varicella. So, and when I was coming back to Sri Lanka, I was talking to my supervisor, and so I learned a lot also on cutaneous immunology. And I said, okay, I'm interested in working on leprosy. And he asked me, why are you interested in working on leprosy? I said, Sri Lanka is one of the 10 countries in the world which reports the highest incidence of leprosy. So it was an important area to work in. He said, no. You have to work on something that is important to the whole world. Okay, otherwise, you're not going to succeed. So it has to be important. Yes, it is important to Sri Lanka and few other countries, but even in Sri Lanka, people don't think leprosy is that important. I mean, that's the sad truth. So because of that, he said no. And he said, okay, find other areas you're interested in. So I was thinking about dengue or TB, given my expertise and what I liked. So of course, I had already started working on dengue. Before I went for my PhD, I had done several clinical studies on dengue. And that's how I ended up with dengue. So you have to think about what are the trending topics globally or in Sri Lanka, preferably both. And do others also consider it important? Because you have to convince others, no funding, no research. Okay? Because there's no way that you can fund research by yourself. Research takes a lot of money. If you can't get funding, there is no research. Okay? So how likely are you to get funding? How well can you sell the idea? Because after all, getting money is about marketing, whether you like it or not. Okay? Getting research funds is marketing. That research proposal is a marketing tool. Not so much in like the research grants we are talking about in the university, but I mean, you can start off with research grants in the university, but I mean, that funds alone is not going to help you go to the next level. So you do need to be able to market your idea. So how do you identify the most important research questions in the field? Of course, you have to read and read and read. There's no other way out. Okay? So everything. So now, of course, in this world where thousands and thousands of papers and preprints are being published every day, how can you actually achieve to read all those things? You can't read like every day, like let's look at dengue. How many papers are published? I can't keep up to date. But what I do is take a shortcut. Okay? First of all, there are two important platforms called Twitter and LinkedIn. Okay, not Facebook. I'm also on Facebook, but I don't go on Facebook that much. There is a reason social media is there, and we can use social media to our benefit. So if you take Twitter or LinkedIn, you don't have to make the other person accept your friend, accept them. You just have to follow them. So then when you follow like the important people in your field, every morning in your Twitter feed or your LinkedIn field, people share their papers. So it's like a journal club. So by the time you spent in the toilet, for instance, okay, I'm just telling you, you can get a lot of information about, okay, what was published. Okay, or you can spend 10 minutes just looking at these feeds, then you can screen the papers, which ones have been published overnight or, during the last 24 hours, which one shall I choose to further read? Then you save it and then read it. Okay? Because otherwise, how on earth are you going to keep updated? So the social media platforms are out there, and please do use them to keep updated. Then, of course, all these webinars and conferences. Fortunately, after COVID, there are many virtual webinars and conferences which are specially free of charge for people from LMICs like us. So Welcome Connecting Science is one of the resources. They have a lot of online conferences, hybrid conferences. So people in LMICs have free virtual attendance, and I subscribe to, attend all these conferences. And of course, the ketone symposia. You can apply for Bill and Melinda Gates travel funds, not travel funds, I mean attendance, and so far I have been successful in getting these things. So these are other options where you can be updated, and because you need to identify the most important research questions in the field. Because it's pointless doing what others have done. Now coming to strengths and weaknesses. Now I'm going to ask you a question here. Now this is again us for COVID-19 research. We have published 35 papers in index journals, 3 on genomic sequencing, PCR, immunogenicity of vaccines, several, all those things. So now, why did we stop COVID-19 research? Of course, why don't I consider myself a COVID-19 expert, and why didn't we do more research on immune responses and long COVID and other things? Why did we stop? If there is a choice, because you have to choose, life is about making choices, and it's important to make the right choices, like marrying the right person. So if you have a choice between working on COVID and dengue, if I have a choice, what choice do you think I should take? Okay, so I mean, I think it's clear. I mean, no point working on COVID for, there is opportunity long COVID. I mean, could have got funds also. But why is it pointless, and why should I keep working on dengue? So it's about identifying strengths and weaknesses. Okay, so the strengths, access to patients, I mean, for both areas, yes. So, but the things that you need to consider, then the disease, whether it's present in Sri Lanka and similar countries. So I'll tell a good example. If you take something like multiple sclerosis, okay? I mean, as a researcher in Sri Lanka, would you work on multiple sclerosis? What is the strategic advantage you have to work on multiple sclerosis? We don't have many patients. In other countries, they have many. They have done so much more research than early career researcher who is just going to start on working on multiple sclerosis. So working on something like multiple sclerosis is useless in Sri Lanka. Okay, and of course, the other advantages we do have is usually lower costs when it comes to patient recruitment, community studies. So even, let's say it's something that is present in high-income countries, because of the way we can do things, we can attract funds and actually go ahead and do research. And if you have a high disease burden, it's easier. Now, if we are working on a disease predominantly present in high-income countries, then of course they would have already been doing lots of research on it. And before we can even think about it, they would finish doing it. Now, a good example is something like long COVID. Okay, because I asked the question, why didn't we work on long COVID? It's because, I mean, we do not have, by the time we actually start with the research and do the research, because of the delays, procurement delays, let's face the truth. How long does it take to procure things with our procurement process? A very long time. Whereas in high-income countries, you order something, you get it in 2 days. Okay, and so custom clearance, everything, right? So it's simply, even if you have the research idea, to start the project, to get the necessary approvals and to start the research project, it takes about 10 times more time in Sri Lanka than some other country. So the time, because speed is everything. So when you actually start your long COVID project, people in other countries have already done so much more work on it and published. Okay, so this is something you need to think of, whether you have a strategic advantage. You have to remember our disadvantages. Disadvantages are lengthy procurement procedures, bureaucracy, custom, things getting stuck in customs, and this is the reality. So when you choose these things, you can't ignore these things. Okay, so you have to put all these factors, you have to take in all these factors when you decide your strengths and weaknesses. Those are weaknesses. You have to, if you don't do a good analysis of your strengths and weaknesses, you're going to lose. So do a good analysis of that. So in that case, shouldn't you choose one of these areas, like cardiovascular disease, diabetes, cancer? I mean, those are present in high-income countries. Shouldn't we do those? Absolutely, we should. but you have to find the angle that is important to us, where there's a strategic angle for us compared to what other people are doing in, let's say, UK or US. You cannot compete with high-income countries. It is impossible when it comes to research speed, the technology available, and so on. It's simply not possible. Okay, so we have to understand that. You can't try and do impossible things. The reality is that we can't compete. In such instance, find the angles that we have a strategic advantage in. So finally, coming to how do you progress in your research area, because especially when you're starting off as an early career researcher, you have lack of funds, limited networks, locally and internationally, lack of access to infrastructure, okay? Not sure how to do things, and also family commitments. I remember when I was like, 20 years earlier, had very small kids. Financial constraints, this is the reality. When you have very small kids and financial constraints, it's very difficult to do anything. Okay, so this is one important thing that young career researchers face. So who should you seek help from? So scientific collaborations are very good, but there are good sides and bad sides. So you have to make sure that you use these scientific collaborations to your advantage. Obviously, scientific collaborations is the way forward. There's no way that you can do things by yourself because your expertise is limited. These days it's all about multidisciplinary. So exchange of knowledge and ideas, expertise, learn better ways of doing things, improving critical thinking, because more people there are to question your research ideas, your research process, the better you're going to become. So you need people questioning you. Without people questioning you, you're not going to be good. But of course, there are bad sides, exploitations by seniors. Thinking this commonly happens, let's face it as well. Then gathering data samples, like especially in foreign collaborations, sometimes foreign collaborators just want to send you to send samples without capacity building. So, I mean, that's the easy way out.
Sorry to interrupt, we have 3 minutes.
Okay, this is my last slide, yes. So, I mean, they just want you to send samples, send the data, and you will, of course, get some middle authorship, and that will be the, so you will have papers, you will have a good H index, you will have a good citations, but you will not be leading your research, okay? So, so when you do collaborations, it's important to understand how to do them. So sometimes you have to compromise, you have to take, it's hard to maintain you leading things, but in the long run, it's better for you. And so last slide, of course, is it's one step at a time for all those early career researchers out there. And it is a lot of hard work, but of course, we have Anjan here as well. Lot of people, one step at a time, you can make it. You have to be patient and at it. Thank you.
Thank you so much, Neelika, for that insightful and thought-provoking lecture and for sharing your experience of the research journey. And it is not only for the early career researchers, I think we all benefit from that. And since we have a little bit limited time, if there is any one or two, we can entertain about 1 or 2 questions. I think it's so thought-provoking, people are thinking about it. Okay, Neelika.
Thank you, and please do excuse me, because I think it's not good for me to give my infection to everybody, and so I will take a leave. Thank you for this opportunity.
Okay. There's a small token of appreciation, please. Yes, Shamini.
Next in line, we have Professor Anjuna Premawardana. Again, not new to the Sri Lankan researchers or the Sri Lankan community. He's a specialist in internal medicine and a chair professor of the Department of Medicine at Kelaniya. He obtained his PhD from the University of Oxford after completion of his training in internal medicine. He is a leading researcher with special interest. I'm sure you all know his interests. It's in disorders of hemoglobin and iron metabolism. His publication is so extensive, and just to sum it up, he has over 2,800 citations with an H index of 27. Over to you, Professor Primo.
Thank you, madam. After that brilliant lecture from Neelika, it's the first time I've actually listened to Neelika and had an insight into how her mind works. I think that's very nice and thought-provoking for anybody. This is pretty mundane stuff, to be honest. Just like in anything, writing a research paper, the first time you try this, just like in love, I suppose, the first thing is always the hardest. And when you start writing, before you actually start doing it, there are three things that you need to fulfill. You need to find out whether you actually have new stuff which is exciting. Then you have to get the content written in a format, in a suitable context, and then you put it in a style which is very and eminently readable. The first thing is the designing part. You have to ask yourself whether you have done something really interesting. You have to compare with the latest literature, and you find whether it is topical and is worth publishing, and your methods are appropriate. Can you describe the research scope? Have you asked yourself and answered questions like the limitations of your own study? Is there a nice story to tell? And again, is this topical? Is this something current? Or are you writing about something which is not interesting to anybody in the current context? And are you answering a difficult question which people are looking for an answer to? If the answer to this is yes, it's time to start writing. Now, before you write, the things you should think of would be the structure of your paper, the language, the technical details. Finally, before you submit, you have to write a cover letter. And once you finish writing, what do you do with it? And the ethical issues, which I'll deal at the end. What kind of a manuscript are you going to write? Who is the audience, the target audience you are going to pitch it to? And what is the journal? Now, there are different types of articles that you can think of submitting or writing it as. It could be a full-length paper. It could be a research letter. It could be a rapid communication, a short communication, case study, case report, or a review. Or it could be a meta-analysis also. So when you have your stuff you are trying to write, you have to design what exactly are you going to write it as. Deciding on the journal, I think there's a full topic on this, so I'm going to skip on this very much, but it's very, very important, especially for people who wish to publish, not to get caught to predatory journals. And the stuff like impact factor of journals, I'm sure will be talked about extensively, so I'm not going to talk about it now. The format, the best instruction is, before you start writing, think of what journal you are going to write it to, the target journal, and based on that journal, read the guide for authors. So there is a bad side to this, because there's a very high chance the first time you write, your article might get rejected. You might have to reformat it and submit it to another, and the second journal might have a completely different guide for authors. But don't be disheartened by that, but it's always good to have the structure based on the guide to authors when you write it. Okay, if you have to go for a second time, do it again. So think of the layout, section lengths, the abbreviations, spellings, the way, whether is it American English or the British English that they want, the reference format they want, the numbering, the figures, the number of figures, the number of tables they accept in the main manuscript, and the statistics the way they want it presented. So it's always better to refer to the guide to authors before you start writing. And the big question for any author you start writing is, where do you start writing? Which part of the manuscript should you start writing in? Now, in an article, let's say it's a big reference main manuscript that you are writing. There are many components. The title, the author, the abstract, and the keywords is the top part. But the main body is the introduction, the methods, results, discussion, and the conclusions, which is referred to as the IMRAD. And at the very end, very importantly, there's the acknowledgements, references, and sometimes, if you have a lot of data, there will be the supplementary materials. Now, where do you start writing? Is it with the names of the authors, or is it with the title? It's best to start writing with the methods. There's obviously no one supervising you. You can start wherever you want. But this is where I think somebody might be surprised. I'm sure most people would want to start writing with the introduction. But experienced writers first start writing the method section, and then go to results, then go to discussion and conclusion, and then introduction, then the abstract, and then decide on a title. So you match the introduction and the title to fit in the work that you have produced. Now, why the methods? Because the method section is the structure of it, how you design the study. And the method should provide sufficient information so that somebody who has never done this will be able to do this study all by themselves all over again. Now, the method section should be very detailed, but not too detailed and not too boring. So it should define, for example, the population and the setting, where was it done, the number of people, number of patients, for example, the method of sampling, describe the instrumentation and where the instruments were manufactured, for example, describe the procedures where relevant, the analysis plan, and how you have ensured the validity of the methods that you have ensured, and the assumptions you made in the methodology that you have taken into consideration, and the limitations of the methodology if that is necessary. Now, it should be detailed, but if there is a technology which has already been very well described, you don't have to give the details of the technology. For example, you don't have to describe PCR technology. PCR technology is very well known. You do, it was done using ARMS PCR, and you give the reference for that. But if you are doing a technology for the very first time, a new technology is being designed, that has to be described. And the equipment has to be described, and the manufacturer has to be identified. When you talk about the results, again, I think there's a full lecture on this, so not going into details. Using figures and tables is very important. The figures and the tables is something which catches your eye, the reader's eye, and it's very important you do not duplicate what is there in the figures and the tables and go into the main text as well. So writing the same thing, very same thing which is in the figures and the tables in your main text is a waste of time. And what is important is to do an interpretation of what is there in your figures and the tables and what you want to emphasize from the tables into the methods, into your results. And the graphics, the figures and the tables have to be selected very, very carefully, because if there are very important graphics, for example, a Kaplan-Meier survival curve, that alone will give you the idea, and that might be the only thing a reader looks at. And that would give you the whole idea of the paper, and if it is descriptive enough, the whole idea of the paper will be sold in a flash. So the graphics should be very clear, it should be sufficiently descriptive, and the legends that are at the bottom of a figure should be equally descriptive, but not too lengthy, but they should be standalone. If you look at a figure and the legend at the bottom of it, you should be able to understand what is meant by that just by reading the figure and the legend. You should not be able to you should not have to go back to the main text to understand what is in the figure and the table. You should not have to go back and refer back to and fro. As long as it is standalone, that's a good figure and a graphic. Statistics has to be understandable. It should not be something which can be interpreted only by a statistician. It should be interpretable by a lay clinician or a scientist. For example, if you used a mean, the standard deviation should be there. If you are giving a percentage, the numerator and the denominator should be there. Simple things like that should always be followed. Now, when you start writing the discussion, this is the selling point. You've done the methods, you've sold your results, done the graphics well, and then you come to the discussion of the paper. This is the selling point. Here you start arguing about what you have found. The discussion essentially summarizes the findings. It puts your findings into context, recognizes the limitations. Remember this, you have to always talk about the limits of your study, and then you argue out how you plan to correct them or how others might want to take this study forward. So the discussion has 4 essential components. Summarizing the findings, not repeating what has already been told in results. It should not be a repetition of the results. So don't reiterate the results, and don't make grand statements. Do not introduce new terms which have never been used in the introduction, results, or methods for the very first time in the discussion. And you can speculate, but speculation should be warranted based on what you have introduced in your arguments before. You can't make again philosophical statements based on in your discussion. Don't use philosophy in your discussion. Research is not about philosophy. And don't be scared to use negative results which have been shown by other researchers, which contradicts to your results. And then comes the conclusions. In your conclusions, you basically describe how you basically sum it up. The entire paper, you sum it up by saying how your work has advanced the field, and then you can here hypothesize how you would plan to extend this further, or how others could take this further. It's kind of a philosophical statement. It is always best not to downplay negative results, and making statements based on personal opinion and repeating other sections and overemphasizing or making grand statements about what you think you have found. And now is the time you can actually do an introduction. Now, introduction is an area where most people get it wrong. Introduction has to be short. Essentially, just 3 paragraphs is good enough. The first paragraph should be giving the context. You identify what the problem is. This is what we know about leptospirosis. There is this disease called leptospirosis. There are 300,000 cases of leptospirosis in the world, 20% of that in Asia. I'm this making up numbers. And then create the second paragraph is to create the knowledge bank. However, we do not know where leptospirosis, how much it causes, whatever, pulmonary injury in Sri Lankan people. So the second paragraph is about what we don't know. And the third paragraph is what we plan to do. So our research, therefore, we try to conduct a study to address the knowledge, the lack of knowledge about leptospirosis and pulmonary disease in the Sri Lankan community. So that's essentially the introduction. It is not a narrative, a history lesson on leptospirosis. It's a short introduction. And very small number of references. And the most up-to-date references should be used. Not the first reference, okay, that's fine, but not all the references. Select a few most useful, latest references in your introduction. So you don't need 20 references, just 3 or 4 would be good enough. And the abstract. Now the abstract, the most important thing to remember is that in papers, very often, it is the abstract and the conclusions that most people read. So the abstract has to be standalone. If you read the abstract, that should be able to market your research to anyone who's not going to read anything beyond that. So it should be, there are different types of abstracts, sometimes with headings, sometimes without headings. So it all depends on the paper that you write. So depending on the paper, the journal that you're going to publish, decide what kind of an abstract you're going to select. The abstract has 3 important jobs. For the writer, when you are writing the abstract, it will tell you, you yourself, the man who has done the work and who has written the paper, what your paper is all about. Maybe for the first time, it will convince you that this is what I've done. So the abstract will convince you the key things of your research. For the reviewer, abstract is what he looks at and will decide, okay, this is good enough for my journal. And for the reader, and he reads the abstract and decides, okay, I'm going to read the rest of the paper. So those are the 3 functions of the abstract. So it should be essentially standalone. It should be precise, honest, standalone, brief, because you know most abstracts is just 200 or 250 words. There's a word limit for that. And don't use abbreviations. And definitely no references are allowed. Now, a big issue is about the title. So this is the time you decide on a title. Don't use catchy titles like doing Sherlock Holmes in medicine, the discovery of neurogenic claudication in a 25-year-old man. That's not a medical title. It should be descriptive, talk about the research, and perhaps even the finding. So you look at it, you know what this research about, and perhaps give the result as well. And remember, looking at the title, you will decide whether you want to read the rest of the research paper. And when you are doing reviews on or writing, you doing meta-analysis, the topic is so important. If your topic doesn't actually tell what the paper is all about, nobody is going to identify your topic or your paper as part of this whole scientific process. So it should catch the theme of your work in as few words as possible. Now, for example, action of antibiotics on bacteria, which is very vague, is a bad topic. For a study where the researcher has actually done a study on streptomycin and found that it inhibits the growth of the TB organism, it is better to show the result itself as the title. It gives the whole story away, but that's fine, because that is what you want to say. So disclosing your result in your title is fine, but don't hide it and try to make it a hide and seek game. You are losing the plot. And then, of course, keywords. Journals will say use 3, 4, 5 or 6 keywords, and keywords are important because that is what people use to retrieve and look at your manuscript. References, different systems are used. Use the system prescribed by your article, by your journal, and when you are writing, preferably use a reference manager, because if you collect hundreds of references, remember many journals want just 30 for manuscripts, and if you don't have a system, entering them is very, very tedious. Supplementary material. Remember, many journals would want 1 figure and 2 tables, but you have so much of stuff you have collected. You have 15 tables. For you, all that is important. You must show it to the audience. But you don't want to not show that. But there is a place you can put it in supplementary where it can be seen by the readers, but it will not be published in the main text. So to sum things up, when you are writing a manuscript, there are 3 C's: clarity, concise, and correct. And the things to avoid is repetition, redundancy, something which is useless, ambiguity, being vague, and exaggeration, saying the greatest study ever on leptospirosis. Never say things like that. And to the last thing, the ethics of this is very, very important. Authorship, gift authorship, bowing down to the senior author and putting the senior author's name. And these are real issues in, as Nilika also said, in Sri Lankan context. Acknowledgements have to be done, but not necessarily authorship. And then, of course, ethics. Ethical clearance has to be given and taken, of course. You submit it and pray to Tistun Kotayak Devidun and be ready for rejection, which is very often than not. And a quality of a winner, of course, is being original and being able to contribute something new and which is written in a very readable format. And what is not wanted is something duplicate repeated articles which have been done over and over again. Thank you very much.
Thank you very much, sir, for the 1090, and it shows the experience on the lecture itself. So the floor is open for discussion. I think we can have one or two. Yes, Dr. Sanath?
Thank you, Professor Anuja, for a very insightful talk. So I really like your idea of when you're writing the manuscript, start with the methodology, because that's what you have done. And then when it's come to the next thing that you suggested is start writing the results. So when you come to the results, is there a particular insight that you can give? Is there a particular order we can follow? Because for me, I follow the order of the specific objectives. But is there any insights that you can provide?
Not particularly. I think it goes with the flow. You know, it depends on, I think when you start writing, you realize that you keep on changing. You know, I think unless you are a born writer and you know, it just happens in your dreams, you know, most papers are written over and over again. So you would write, so you have this, you have the methodology, you have the main objectives. So it, you try to argue out according to a certain flow, but then you can change to fit a certain flow depending on what you see as the priority. No such set thing, but it's all about readability and highlighting the key points early on, and I suppose the most important things have to catch the eye. I don't think there's a specific order as such.
Thank you, sir. Any other questions? So I have one, I think. Going with the theme of the conference with advanced technologies or AI, I know the younger generation is using AI a lot to write up manuscripts. What is your advice on that?
I'm actually going to listen to the talk on AI today because I'm trying to learn that myself. I am still manual and you know, just I'm trying to learn it. So let's see what, I think there are 3 speakers today on that. Let's ask that question from them.
Thank you very much, sir. Thank you. And as a token of appreciation, may I ask Professor Pradeepa to hand over the token of appreciation to us.
Next is the last talk on this symposium, and it's on presentation of results, figures versus tables versus text by Professor Anjana. Professor Anjana Silva is a professor of parasitology at the Faculty of Medicine, Rajarata University, and an adjunct senior research fellow at Monash University, Australia. He obtained MBBS and MPhil from the University of Peradeniya and PhD from Monash University, Australia. He's a fellow of the National Academy of Sciences of Sri Lanka. Professor Silva started his research career as a young biologist and discovered several new species of endemic reptiles and fish new to science. His current research focus is on snake envenoming. He combines experimental, clinical, and epidemiological studies to answer research life clinical questions in snake envenoming.
Thank you very much, Pradeepa, for the nice introduction, and very good morning to all of you. Well, I think I must first thank the research committee of the Faculty of Medical Sciences of Jayawardhanapura for inviting me. I think this first having listened to the two eminent speakers before, actually those two talks really inspired me as well, so there were lots of things for me to learn as well. So this topic, actually, presentation of results, I had to do a bit of reading as well to get prepared. So that also was quite a good learning experience for me as well. So now presentation of results, how do we present them effectively using figures, text and tables. Now there's no, proper course or anything that someone can follow and then ultimately learn these things. It's all about, start from the, whatever the knowledge you have, and then keep doing mistakes and learning from them and all that. But there's two important things actually when it comes to learning that helped me was one was when I was doing my PhD. My supervisor was clinician scientist, so he has this very good understanding of not to get lost among data and how to present them in a more effective way. The second thing was when I was so there's a journal called Clinical Toxicology, which I am editorial board member. But when they recruit editorial board members, they give a 1 year apprenticeship under a senior author, a senior editor. So basically they train us how to look into the data, especially, and how effectively we can deliver data. So apart from those two, others are basically for me self-learn and all that. And I hope there are many eminent scientists here as well, and they also maybe have their inputs at the end of this talk, because there are things still I'm learning. So now this day and age where we do quite a lot of research, cutting edge research, and then publish them in good journals, sometimes we tend to forget what we are actually doing by doing research. So what we all practice here is Western science. We practice Western medicine, so that we have to understand. So the core principle or the fundamental process of producing knowledge in Western science is scientific knowledge. That's what we do. We can't forget it. So basically we make observations, we ask questions to explain these observations, and then if we can explain these observations by getting into the knowledge base that the humankind have developed over the last whatever several 100,000 years, and then whether we can explain our observations from what other people have found out. So that is the core idea of doing a literature search in a research paper. That's why we basically do a literature search and find out the key knowledge gaps. And based on that, we make various hypotheses. We plan to test the hypotheses by doing experiments, and then collect data and come into conclusions, and then we share our results. So sharing results is very important, because that is how we share with the other humankind or people in the in the same field or whatever, what we have found, so that they know and they learn from what we have done. And then also they based on what we have found, we develop new interventions, and then also we start asking new questions, and other people also ask questions. So this sharing results part is very important. This is not only limited to just results, as Professor Premwardana also clearly mentioned. It's all about communicating the entire thing, whether other people can actually reproduce what you have done. So that should be detailed enough. So when it comes to presenting results of a research paper, right, there are few general rules. You have to only present key findings related to the aims, and they should usually appear in natural order, right? Subsections usually similar to the methods. And the text is the most basic form of presenting results. Text is the most important. And this text can be appropriately supported by data visualization. So what is data visualization? Usually using figures and tables to effectively deliver the content. And there are certain important things, as Professor Premvardhan also said. Do not duplicate information, because we have to respect the intelligence of the readers. You don't need to repeat everything that's in the text, in the tables as well as figures. And strictly no methods in the results. Methods should be in the method section. And we present in the results only the data related to the aims, not other data accidentally you found during your research, and don't try to put them all in the results section. And you should not present data where you have not described the methods. And then absolutely no interpretation of data in the results. That part is in the discussion. And then usually no references. In most of the cases in the results you don't present references. And in the text, that, as I said, text provide the fundamental narration. Sometimes there may be papers without a single table or a single figure. Just text would be enough to give the whole idea with the statistical analysis as well. Simple, clear delivery can be there without tables or figures. And as again previously said, all tables and figures must be cited in the text, because text is the most fundamental form, and they should be numbered according to the order of citation. So now we know why we use text, and then why do we use figures. So whenever we want to show some data patterns, certain trends and certain associations, and also some outliers, then figures are the best. You can convincingly show that. So we use tables when we have sets of data which are a bit too complex to write in text. So the most effective way would be to put in as a table and then write the essence of it in the text. So figures. Now when we call figures, it's a very broad term. I mean, that includes various types of graphs, diagrams, and some heat maps, GIS based geographical maps, images, spatial images, schematic drawings, and all that. And sometimes a single figure can contain a bit of everything, depending on how it makes sense. But whatever the figure is, it must be accompanied by a detailed caption that includes a declarative title, methods, and statistics. And as it was previously said, figures and tables both should be able to stand alone. Anyone should be able to just read or look at the figure and understand what it is without referring back to the text. And there are of course some figures which are more specific for certain types of journals, for articles. For example, randomized control trials, or even systematic reviews and meta-analysis. There are certain types of figures like flowcharts, recruitment flowcharts, consort diagrams, and so on. They are pretty standard. In a meta-analysis, maybe you have a forest plot or anything. I mean, those are pretty standards. Everyone expects those figures to be included in that sort of articles. But in general, now this is a figure. Now it has a figure and the caption, and within the figure there are figure panels. So sometimes you may have just one panel for the figure, or there may be several panels. Now if you are presenting panels, panels should be labeled properly. Put a sub label, like for example, if figure number 5, 5A, 5B, likewise for the individual panels. In the caption there's a title. There should be a title, and then usually there's a methods part, that means describing each and every panel, and then there's a statistics part to interpret the figure. So this content, if you have this content, usually it's very self-explanatory to anyone who reads. And then using different types of figures it all depends on the type of information that you are going to show in the figure. For example, if you are going to show amounts or compare amounts, then group bar charts, like sometimes horizontal bar charts, stacked bars, so bar type graphs are more appropriate. Whereas when you want to show XY relationships, scatter plots, bubble charts, and then paired scatter plots, and various types of different ways of showing XY relationships. And distributions, usually box plots, scatter dot plots, likewise there are different types. And also proportions, pie charts, again bar charts, so various types of charts that are more suitable for presenting different types of data. And also one other important thing about showing or making figures is that focusing attention on aesthetics, that is positions of various icons, symbols within the graph, and also shapes that you are going to select, and relative sizes of the shapes, and the colors, what kind of colors you put for various columns, maybe sometimes parts of the pie chart, what kind of colors. And then the lines, if you are using lines, how wide the line is, and what type of line, whether it's interrupted or continuous. So these information is very important, and within a paper to be consistent across the different figures as well. For example, to indicate now, if the first figure shows something for a certain, for a certain parameter, blue color was used, and the second figure, another color was used for the same parameter, then it's confusing. So this kind of consistency is required when it comes to making good figures. And especially I think many postgraduate students are here, they love to use these pie charts, right? So pie charts, the problem is, I mean, this is a pretty bad pie chart, right? If you want to show males and females, okay, 60.87 males, and then 39.13 females, you don't need a pie chart for that, for the first place. You can just, from one sentence, you can say males 60.67, that's it. Then everyone knows the rest is females. So just editors just hate this kind of information. So they basically don't want, and you can basically not to use a pie chart in this kind of situation. But pie charts are important in a way if you use it in a wise manner. For example, now bear with me, I'm a snake bite person, so some of the figures that I use are related to snake bite, but can't help. So now the other one was basically comparing the venom profiles of a different species of cobra and what kind of toxins they have. So there you give a better understanding. So a toxin group in red color, how it is represented in different snakes. And so you combine pie chart in a hierarchical tree and show that how it differs. So this gives some sense. And then one other thing we use is that, showing trends. We try to show trends using graphs, right? Sometimes, along a certain time of time, you show certain parameters, right? You may use median or mean lines, but always better to show, while doing that, actual data as well. We call them noodle plots or spaghetti plots. And also, if you are delivering content, especially with regard to clinical evolution, still you can use similar types of graphs where one axis is basically about advancement of clinical severity, whereas the other one is time. So these are all noodle plots. And also to describe and compare distributions, we often use dot plots or box plots. And even if you are using a box plot, sometimes better to show the outliers as well to clearly show how many people do not fit into the confidence intervals. And sometimes you can do some added things. For example, now in this graph, you see we are comparing three things. and phospholipase A2 activity of 3 groups of patients. And you see one set of data is widely distributed, right? Therefore, the scale is very long, so that the other 2 groups, their data range is very narrow, so you can basically see what is going on. So easy thing is to make the y-axis a log 1. When it when you make the y-axis log, then everything stretches up and you can easily demonstrate. So you can easily do these things with software like GraphPad Prism that everyone uses. And then certain things that you should avoid is probably like this. Now this graph, right, you see it y-axis starts from 50,000, so that it actually creates a visual illusion. The idea of the presenter is to show that there's a big difference between all 3, but it's actually confusing and misleading. So if you have to present the data properly, then you have to start with 0 and show. You may interrupt the axis in the middle, that's fine, but start with 0. Likewise. And also, some effective ways of using figures is timelines, especially in case reports. You can create a timeline so that visually anyone can understand what happens to the patients along a time period. And also, flowcharts. Flowcharts are also important, especially in observational studies. Sometimes people describe results of observational studies and start up with the number of patients that they have recruited without going into details of how they actually selected them, how they excluded some of the patients, and due to what reasons. So those are important. And when it comes to tables, if you have repetitive tables in manuscripts, that means the same format of table coming again and again. You can combine them, definitely combine them, avoid lengthy and complex tables, and titles also should be as informative as possible. And then usually you have to divide data, right? If there's large amount of data. Now you can, what I mean is that within a single cell, if there's a lot of data, you can still either divide them into different columns or rows. And within figures, it's always better to minimize the abbreviations. If you use abbreviations, definitely you have to then and there define under the table as a footnote what do you mean by these abbreviations. Now there's a few examples. Now one is, the top one is basically an ugly table where you see the content, the text is actually center aligned. It should be left aligned. And then the numbers, digits, if you have more than 1 digit, then that column should be right aligned. And then if you have single digit, like the rank, in this one, it should be center aligned. And horizontal and vertical lines within the table, you should remove them. So that is how you format a table. And also, one mistake that people often do is oversimplifying data. For example, the first one looks a bit complex, but it basically includes most of the information that you require. But then sometimes people want to declutter it and make it more clear and more visually appealing. But in that sense, that is not good for a research publication, maybe a general talk or just a public speak. So in other terms, you should not dumb down the information that you present in graphs, because you have to always respect the intelligence of the readers. And then aesthetics are very they really make sense and they matter a lot. For example, now if you have a graph, proportionately the size of the fonts in the x and y axis labels and also the numbers, they should be readable compared to the icons that you include in the graph. So you have to be focused on that as well. And also, one thing that people often do is, suddenly when they analyze data, they found some odd associations which they can't really describe, but still think this is a good finding and try to present. One thing is that now there can be very accidental associations, which does not mean anything when it comes to causation. So, but still, like for example, in this one, a divorce rate in one of the US states, whereas per capita consumption of margarine in the country, but they very well correlate, but doesn't make any sense. People sometimes, especially in student thesis and all that, they present things like that which they can't really explain. So before adding a table or figure to a research paper, you have to always ask, do I really need to include this figure or table? Does it add anything? If not, remove it. So if it is not serving the purpose, probably it's misleading the reader. So better to avoid using it. Finally, the key message is results are the center of attention. There should be a logical flow, and it should be clear and succinct, and text is the most basic form, and always figures and tables should complement what is in the text, and always recheck whether they are essential for the story and are not misleading, and they should be visually pleasing as well. Don't use different types of fonts in your, your figure A is at one font, figure 2 is another font, colors messed up. So those are visually, not nice. And editors basically hate that kind of thing. So basically try to be consistent across your piece of work. So one good reference for students to follow is this Fundamentals of Data Visualization. It's free ebook. This is the link, clausewilk.com. This actually has a comprehensive guide for how to effectively deliver data in research publications. So basically that's it. Thank you very much.
Thank you very much, Anjana, for that very informative and descriptive sort of description on how to present figures and tables. We're attending to a lot of details, and I'm sure that has given a lot of information for our young researchers. Not only young researchers, we as people who guide them, I think it's very informative. Thank you so much. So now the floor is open for discussion.
You mentioned some softwares and apps which are instrumental for figure generation. Can you mention those?
I actually use only the Prism. That is because it is easy for what I am doing. I think Prism, basically GraphPad Prism, is capable of basically doing everything that we all need to do in our type of medical research. And at the same time, Prism allows you to do the statistical analysis as well. Once you upload the data set, it basically does the analysis and include the analysis into the figure as well. So you can do lots of changes with the figure, Prism, but I have not used any other, I have no experience with the other softwares, but I think Prism is a really good one, and that's basically what I am stuck with.
That's useful for graphs as well.
Yes, graphs. It's called GraphPad Prism. So basically making graphs as well as analysis, including analysis into the graphs as well.
Any more questions? In the absence of questions, may I invite Professor Prathapan to hand over the certificate of appreciation.
What an insightful overview in one of the most impactful aspects of a research. Thank you, dear professors, for guiding us through those interesting sessions. After a healthy discussion, now it sure is time for some refreshments. Ladies and gentlemen, refreshments will be served in the adjacent hall, and the next session will be starting at 10:35 a.m. So this is a kind reminder to be back at your seats by that time. Thank you.